Yes, I have spoken at CrikeyCon a bunch of times in the past, but I was astonished when I checked my talks repo to see when was the last time. It was all the way back in 2019, 6 years ago, so it's great to be back up on the stage here at CrikeyCon. Have a QR code. That links to the slides for this talk if you want to follow along. There are quite a few references in the deck, so again, grab a photograph of that or scan it now, and it will be at the end of the talk as well. My audience interaction hook has been usurped. I was going to ask, hey, when you think of one picture to describe open source security, what do you think of? And someone was going to yell out, oh, that XKCD, and oh, anyway, there it is. So why does open source security matter? And supply chain security? Well, you can almost see a massive intersection between those two topics because open source is at the foundation of the software supply chain. There's very little software out there these days that is not using open source somewhere in the supply chain. There are very few organizations that are not using open source software somewhere in their supply chain or in the supply chains of the products that they are depending on. So everyone needs to care about open source security. Additionally, there are a bunch of standards and regulations that nowadays really require you to care about the security of your supply chain, and that includes open source. So ISO 27001 de-risking, the NIST secure SSDF, what's that? Secure Software Development Framework, in conjunction with Executive Order 14028, which is around procurement in the United States, saying to government agencies, your products that you are buying or services that you're using have to prove that they have secure development practices, which includes security response mechanisms. And the EU Cyber Resilience Act, which was passed last year, is requiring more nowadays, not only of market participants, the vendors and the companies that are buying it, but also open source organizations and foundations. So everyone needs to care about this. To give an example, this is the text, or some grabs from it, from the Cyber Resilience Act. Open source software stewards, that means foundations and organizations overseeing free software projects or open source projects, shall put in place cybersecurity policies that promote the effective handling of vulnerabilities, foster the voluntary reporting of vulnerabilities, and promote sharing of information concerning discovered vulnerabilities. And there's a whole lot more in it. It's great reading, I can tell you. So, summarizing, supply chain security has always been important. It has never not been important, but now organizations and vendors and people using any sort of software products are forced to care more about it now because they've been forced to. Therefore, open source projects and ecosystems lacking an effective security apparatus will be left behind. So, who in the open source world needs this sort of security response apparatus? And by that I mean a team and policies and mechanisms in place to handle vulnerabilities, to disseminate information about vulnerabilities, and to fix things. Operating systems and distributions, programming languages and their library ecosystems. For example, Python and the PyPI, or JavaScript with NPM. Frameworks, so Spring, Rails, all of these kinds of frameworks and any other sort of major frameworks. So you can think of things like game engines and all those sorts of things. Applications like LibreOffice as an example, and network servers, so HTTP servers, Apache, Nginx, and every other kind of network server you can think of. Other large projects, things like Android or Kubernetes, large projects with a lot of software, a diverse array of software under the umbrella of a particular project, they need a security response apparatus. And one such project that didn't have and needed a security apparatus was the Haskell programming language and its library ecosystem. And I work at Red Hat, and in my day job I write a mix of C and Python and Golang and JavaScript or TypeScript. And then I go home and in my free time and weekends, I like to cleanse myself with functional programming and the Haskell programming language. So the Haskell Foundation, there is a foundation. It has some sources of funding, mainly companies who are using Haskell, as well as universities, because Haskell is a popular research language. So the Haskell Foundation people sort of realized, we sort of need to put some kind of security response mechanisms in place. We probably want to get an advisory database. So they put together a tech proposal to the community to say, hey, this is what we want to do, please comment on this. And so, yeah, Fraser entered the chat with his opinions. Having worked at Red Hat for more than 10 years in security-related products, I have some understanding of how open source security response works in practice. So I gave a bunch of comments about the proposal, about the advisory database, what it should contain, how it should operate, and the then executive director, David Christensen, came back to me and said, well, it sounds like you know what you're talking about, so why don't you put together the team and lead the team? And I said, okay, I've put my foot in it. Well, I guess I have to do it now. So, how to build a security response team. First, you need to think about the kinds of skills that you want across the team. Not everyone will possess all of these skills, but across the team, you need to hit most of these. You're going to need technical skills and knowledge of the project or the language. You also need cybersecurity specific know-how, and that should encompass, depending on your project, application security, incident response, GRC, that's governance, risk and compliance, penetration testing, identity management, vulnerability research, and the list goes on. Most likely, the security team will need to do some software development, developing tooling or integrations with tooling in order to affect security response for that project or ecosystem. And good communication skills are a must. So that's just a snapshot. You, in your projects, might be able to think of other specific skills that would be necessary. This is not a perfect list. And you may think of things on this list that aren't relevant to your project, and there are almost certainly things missing from this list that each specific project or ecosystem might need to consider. Then you need to think about who is going to be on the team and how many people is the right number. Well, one is not enough. You definitely need enough people to cover a broad set of those skills from the previous slide. You need enough people in order to be able to tolerate absence of one or two people. But on the other hand, you definitely want not all of the security-aware, security-minded people in your project or ecosystem. If you have everyone involved all at once, then there's absolutely no capacity to deal with people retiring from the team, deal with extended absences or burnout. So you need to keep some people in reserve if you possibly can, so that the team composition can evolve over time. Diversity is good, of course. So if you can get people with diverse cultural and linguistic backgrounds, people in different time zones, so a security response can be affected maybe at any time of the day because people are awake. People who aren't all dudes, that's kind of something aspirational in the case of the Haskell security response team at the moment. But I shouldn't need to explain why having diversity in your team is a good thing. In terms of the specific number for the Haskell team, we started with 5, and more recently we grew it to 6 people. We had one person retire from the team. We recruited 2 new people into the team. And in this process, both the initial recruiting and then later a second call for volunteers to replenish and grow the team, we had more people who would have been qualified and great to have on the team applying than we needed. So what do? We want to keep people in reserve. We want to remember who they are so that if we need to reach out and recruit someone into the team on short notice, we can do that. You need to define the scope of your work, and I can tell you right now, you can't possibly do everything that could be done. You will not have the resources. The most important thing that is in the scope of the security response team is responding to security incidents and to security reports. So you need to be able to triage these, to analyze reports and propose action, and to coordinate, in the case of a library ecosystem for a programming language, coordinating with maintainers and stakeholders. The team should publish advisories for the security issues that arise within the ecosystem. Overseeing project infrastructure and the security of that infrastructure is another important activity. The kind of project infrastructure that arises in the case of a programming language will be things like build servers, messaging boards and chat servers, and testing infrastructure, CI, all of that sort of stuff, mailing lists. The list goes on. I'm sure you can think of other things. Developing developer tooling. So you got your advisory database, great. How are people actually going to use the data in that? I talk in a few slides time about that, but is the development of that tooling within the scope of the work of your security response team or not? That's something you need to decide. In the case of Haskell, actually it's out of scope. Within scope is we will work with them, we will update the database and the library support that we have for interacting with the database. That is tooling that we own. But downstream tooling for auditing or doing other things with those advisories, that's actually out of scope of our work. We want to support other people to do that work. And then you have communication and community engagement, so reports, guides, documentation, and getting out into the community. So, you need to decide your scope. You can review and change your scope over time, but you need to choose a scope and stick to it and make sure that you prioritize that most important work of incident response, dealing with security reports, and getting advisories out there. Your call for membership or call for volunteers, I've got a link to an example in the deck there, but, well, I can just show you the Haskell one. So, we just have a preamble, outline the responsibilities of the security team, and the kind of attributes and the experiences that we want covered in the team so that people can look at that list and think, oh, I hit a few of those points. I'm interested to help. Maybe I'll apply. This was our second round after we already formed the team, so we explain, okay, this is who's already on the team, and then the application process. So how should you apply if you want to apply? Yeah, sorry, skipped a slide. So processes and communication. You'll need to define your reporting and disclosure processes that people in your ecosystem or from outside your ecosystem who want to report an issue should follow. So this needs to be defined and publicized. You'll need a way to communicate privately as a team, so a chat channel, a mailing list, something like that. You should have meetings. Currently, for the Haskell team, we meet every 2 weeks, and because we have people across different time zones, each of those 2 meetings in a month are in different times. You should produce activity reports to let the community know what you're doing. We do them quarterly. And then getting your people out to conferences, engaging in discussions that are happening within the community, having an office hours for other people to come and engage with you. These are things that you should consider doing also. And then the boring technical stuff, so the actual advisories and the tooling. You will need to decide whether to use your own namespace for your advisories or just whether to use CVE identifiers. In the Haskell project, we have HSEC advisory, so we have our own namespace. If you use CVEs, you'll then be faced with the decision, should you become a CVE numbering authority, a CNA, or not? The main advantages of being a CNA is, first and probably primarily, you can suppress bogus CVEs, and some projects have a big challenge with this, or did have, and then they became a CNA so that they could make all of those things go away. The AI slop is real when it comes to CVEs. And it also lets you produce high-quality CVE records. However, you can use existing CNAs, and particularly if you're a smaller project or you're just starting out, that might be where you want to start, and you can always become a CNA later. The content of an advisory, you need a description, and you should give as much detail as possible. You'll have to indicate the affected packages and their versions, CVSS scores, common weakness enumerations. These are very useful, especially for programming language, library ecosystems. You'll need a way to indicate aliases. So we have HSEC advisories, but many of our advisories also have a corresponding CVE or a GitHub security advisory, so we have to indicate related identifiers for other vulnerabilities or the same vulnerability in a different namespace. And as many references as you can, so references to reports, proofs of concept, commits where the issue was introduced or fixed, all of these sorts of things, blog posts, and so on. This is what the source for a Haskell security advisory looks like. It's just markdown description with some TOML metadata at the front. So yeah, just in case you were wondering. And our advisory database is a Git repo. In terms of consuming the advisories, we export to OSV, that's open source vulnerabilities, which is a advisory information interchange format. We also produce an HTML index of all our advisories and a snapshot format that can be consumed by downstream tooling. On OSV, there's osv.dev. This is a project run by Google. It ingests and aggregates advisories from many different databases. OSV itself is a JSON format. The link to the schema is in the slide. And if you want to integrate with OSV, which you should probably want to do, then you will need to publish your OSV export somewhere. You can file an issue and ask osv.dev to integrate your database into the OSV system, or osv.dev. And in terms of some specific stuff around whether you have a special Snowflake versioning scheme for your ecosystem, or how to enumerate the versions of the packages in your ecosystem, they might ask for a bit of help with that stuff. So this is osv.dev. I've got this, let's see, vulnerability database. So this is filtered down to package, which is the Haskell package database, but you can see all the different ecosystems there that are currently integrated. So NPM, Maven, Fedora's in there as well, are they? No, not Fedora, Debian's there. So yeah, you can export your OSV. This is currently the list of ecosystems that osv.dev is ingesting. We can filter by ecosystem. There's a list there. This is what an individual advisory looks like. So the markdown description is rendered, and yeah, all the metadata up the top. Okay, pretty self-explanatory, hopefully. Package repos, so PyPI, NPM, Hackage in the case of Haskell. You'll probably want to integrate your advisory information into your package database so that people can see which package versions may have vulnerabilities. You can link to the advisories, and crucially, in your package index, your web package index, you should try and provide, at the very least, information about how or where to report security issues, and if you're able, some sort of form or actual mechanism for someone to perform that, to do that process within that site or from that site. That would be very desirable. Audit tooling, so when you have a build plan for a program or a lock file that specifies the dependency set and the versions, you will want a way to analyze those artifacts for vulnerable package versions. So you're going to take the advisory, information and use that in some tooling that can help developers weed out vulnerable dependencies. You can do call analysis. This is more advanced. It's not always feasible depending on the project or the language. And a good starting point is OSV Scanner, which is a scanning tool that reuses the OSV database, which aggregates everything. So if you want to bring your ecosystem to OSV and then do some work to integrate the detection capabilities into OSV Scanner, it's a good starting point. Sometimes a package that has a vulnerability, when used by some program or transitively by some other dependency, that in that context it may not actually be vulnerable, and so you want a way to suppress false positives that would otherwise arise in these dependency trees. VEX, the vulnerability exploitability exchange, say that 5 times fast, is a data model for exploitability information. And you can look at integrating VEX data into your tooling and distributing that VEX data possibly through your package database or through your advisory database or your package database or some other clearinghouse in order to get that information into your tooling so that developers and users aren't spammed with a million false positives. When you have a vulnerability database, the aggregate of this information can give you some really powerful insights about the kinds of issues that most commonly arise in your ecosystem. So you can think of a OWASP top 10, but just for your ecosystem, what are the top 10 issues for Haskell packages? We can learn that and communicate that with our community. And you can also use this information to help identify problematic packages or abandonware that's in your ecosystem, and then make that knowledge, I guess, more public so that people can take action. Corollary of this is that historical advisories are also really important to get into your advisory databases. As a security team, you will need to deal with embargoed advisories, but depending on your capacity, you'll need to set some threshold for like what will you treat under embargo and what will you just get out there, because you cannot possibly deal with every security issue as an embargoed security issue. You've got to set a threshold somewhere for, what is the impact threshold for a particular vulnerability that will cause us to embargo it and deal with it under embargo. Where you have a vulnerability under embargo, you need to know who your downstream distributors are or other stakeholders that you want to inform about this issue while the issue is under embargo. So you're going to need to find out who those organizations or individuals are and maintain a private list of them. Or it could be a public list, I guess. Sometimes a vulnerability spans multiple ecosystems, and so you'll need to work through some mechanism to deal with other ecosystems. One really powerful system for doing that is VINTS, which is an initiative of cert.org. And this enables cross-vendor collaboration on embargoed security issues. So when you start your security response team, or if you already have one but you're not yet on VINTS, you probably want to get there. Then the security response team could also possibly oversee a bug bounty program or some kind of software security audits. If you can fund these activities, great, but the most important thing is to fund your incident response and your security response capacity first, which leads to the very important topic of sustainability. A not good scenario. Critical issue is disclosed and acknowledged. Yep, this is a problem, but it requires significant coordination and effort to resolve this issue, and all of the security response team or the maintainers of the affected program or package or infrastructure, they're all tied up. They're busy with their day jobs. They can't just drop tools and deal with this issue. And so for a long time, you may have a critical issue there unfixed, and who knows when the bad guy's going to discover it and exploit it. So this is the sort of situation we want to avoid. The bottom line, feel free to photograph this slide. Open source ecosystems need personnel with capacity and authority to respond immediately to security incidents. What does not work? Empty words of support. Yes, we support open source. Yeah, go you open source people making so much value. Yeah, we support you. Fix your stuff. Yeah, great. Burying your head in the sand about the state of open source security and the fact that it is critically underfunded. It's not going to help. A few $1,000 here and there. Every dollar helps, but a developer can't live on a few $1,000s a year. Thoughts and prayers. So things I have observed. Sometimes company employees doing security work, full-time or part-time, because their employer understands that they are critically dependent on the security of such and such an ecosystem. What is the programming language stack that you're using? What are the frameworks that you're using? Do those ecosystems have a sustainable security apparatus? If not, either fund the work or let your developers work on those issues. Many projects have foundations, and the foundations can fund people to do security work or can fund specific projects like audits or like a particular tooling project. Grants for bounties or for ad hoc projects are another source of funding. A few examples there. Particularly like to call out the German Sovereign Tech Fund, which puts a lot of money on the table for a lot of really important projects. And all volunteer efforts. Okay, the Haskell Security Response Team is here. We would like to change that. Things that might work, if you only have a little bit of money on the table, a volunteer security team with a paid lead. Is that going to be a bit awkward? Maybe. It's better than the situation where there is no one who has capacity and authority to deal with security issues when they arise. Another possibility is foundation funding developers to work on a whole array of things within that ecosystem, but they have authority to drop tools and deal with security incidents when they arise. So they might not be full-time dealing with security stuff, but in their job description, that's the priority when those things come up. So I mentioned already grants and foundation funding. If your ecosystem or project is big enough to have a foundation, that foundation should be funding security work among whatever else they want to do. Another interesting possibility is a subscription program. So commercial users or other parties with money who are interested in that project, who are depending on that project, could directly fund the security team and in return get a heads up on live issues, a say in the development direction of the tooling, and possibly access to the team for consulting or advice. What are the moral obligations? The Harvard Business School published research last year about the value of open source, and there's just a couple of numbers to pull out here. So the supply-side value of open source software estimated at $4.15 billion. By the way, this didn't include operating systems, so this is probably a big underestimate. The demand-side value is much larger at $8.8 trillion, so something like 3,500 times bigger. Yeah, some massive asymmetry there. Firms would need to spend 3.5 times more on software if the open source software didn't exist, on average. So, your organization is using open source software, they're getting a lot of value out of it. Please contribute to the security of the ecosystem. If you depend on free and open source software, you should contribute to the security of those ecosystems directly or indirectly through foundations. And if you do not do that, you do not have the right to complain if something is vulnerable, if something is broken, and you do not have the right to lean on anyone to fix it. Also, if you're the government, I'm sure there's government people here today, funding free and open source software security work, highly recommended. Consider establishing a grants program, or giving money to those projects that you, as a government department, are using directly. For authors, what are the moral obligations? Now, people have different views on this. This is my view only. a reasonable effort not to deliver insecure code, and a reasonable effort to fix discovered issues. But what is reasonable depends on the level of financial or in-kind support that the developer is receiving in respect of the affected component. If they're not receiving any support, then their obligation is 0. Okay, so let's wrap it up. We discussed why open source security matters, how to bootstrap and run a security team, advisories and related tooling considerations, and sustainability and funding. That's the end of the presentation. There's the link again to the slide deck. That's it. Thank you very much.
Thank you. While I've got the mic, I just want to publicly apologise to Fraser for killing the first slide of his presentation. I hadn't seen it, I promise. I also just want to say thank you. I know, and Fraser's obviously talked about it a bunch here, I know there are a bunch of people here today that also contribute to, as well as maintain, open source components and products. You make the world spin, and we know that, and there's a bunch of practical stuff we all need to take away and talk about in our day jobs, but just thank you on a personal and individual level, because it's awesome, so thanks.